Welcome to the Explainer. Today we're doing something a little different. We're not just answering a chemistry question. We're going to learn how to crack the code of the exam itself.
Okay, so let's get right into it. The question is, how do you nail a big 17-mark question and get every single point? Now, I know it can seem kind of daunting, but trust me, the secret is all about understanding what the examiner actually wants to see.
So look at this. On the left, you've got the question, the challenge. And on the right, that's our secret weapon. It's the official mark scheme. Think of it like a cheat sheet, the code we're going to use to build the absolute perfect answer.
All right, first up, the big one. This is the first part of the question, and it's worth a whopping 6 marks. We've got to plan a whole experiment method.
So the challenge is simple. Plan an investigation. We need to figure out how the mass of sodium carbonate changes the temperature in a reaction. The whole goal here is to come up with a method that's clear, logical, and scientifically valid. To get those top marks, every step needs to be in the perfect order.
And here's what the mark scheme is looking for. It's all about a logical sequence of actions. Step 1, you measure out a set amount of acid. 2, you record its starting temperature. 3, you add a specific, known mass of your sodium carbonate. 4, give it a good stir. 5, you watch that thermometer and record the highest temperature it hits. And finally, step 6, you do it all over again with different masses. See? It's a clear, repeatable process.
But wait, there's more. This next part is absolutely crucial for getting those top marks. You have to talk about your control variables. The things you keep the same to make sure it's a fair test. To get into that 5 or 6 mark band, you've got to spell it out. You'd say something like, I'm using the same starting temperature, the same volume of acid, and the same concentration of acid every single time. Mentioning stuff like this tells the examiner, hey, I know what I'm doing, I'm thinking like a scientist.
Okay, method down. Now let's switch gears to the next part, decoding a data graph. This is such a huge part of any science exam, so let's nail it.
So, the examiner gives us this graph showing the students' results, and the very first thing they ask us to do? Calculate the gradient of that line of a best fit.
And hey, they even give you the formula. Gradient equals the change in temperature divided by the change in mass. You don't even have to remember it, you just have to use it. It's right there for you.
Okay, so how do we do it? You're going to want to draw a nice, big triangle right on that line of best fit. Seriously, the bigger the triangle, the more accurate your answer will be. So let's pick 2 points, say from 1.0 gram up to 5.0 grams on the x-axis. That's a change of 4.0 grams, right? Now we just look at the corresponding y values. At 1.0 gram, the temperature is 22.2 degrees, and at 5.0 grams, it's 28.6. So the change in temperature is 6.4 degrees Celsius.
Now for the easy part. We just plug those numbers into the formula. Change in temperature, which was 6.4, divided by the change in mass, which was 4.0. And that gives us 1.6. Boom! Just by drawing that triangle and doing that simple division, you bagged yourself a cool 3 marks.
But hold on, don't move on just yet. You cannot forget the unit. This is worth a whole mark on its own. The y-axis was temperature in degrees Celsius, and the x-axis was mass in grams. So, the unit is degrees Celsius per gram. It's such an easy mark to lose, but it's absolutely vital if you want full points.
All right. Next up, the question wants us to figure out the initial temperature of the mixture. And it even gives us a huge hint. It's the point where the line would hit the y-axis. Which makes sense, right? That's the temperature when the mass of sodium carbonate added is 0.
So what do? We do something called extrapolating. It sounds fancy, but all it means is you take your ruler and you extend that line of best fit backwards in a perfectly straight line until it crosses the y-axis. Then you just read the number. It's as simple as that.
And if we follow that line back, we can see it hits the axis at 20.6 degrees Celsius. And don't worry about being absolutely perfect. The mark scheme actually gives you a little bit of wiggle room, usually about half a small square. So as long as your line is straight and you read it carefully, you're going to get that mark.
Okay, we are in the home stretch now. Let's get into the final part of the question. I like to call these the quick wins. They're fast, theory-based questions where you can just hoover up marks if you know your stuff.
First one was multiple choice about the reaction profile. The mark scheme tells us the correct option is C. And why is that? Well, because this is an exothermic reaction. It's giving out heat. That means the products end up with less energy than the reactant started with. So the graph has to finish lower than it began.
Next, we had to label the reaction profile. That hump that the reactants have to climb over, that's always the activation energy. That's X. And Y, the difference in height between where you start and where you finish, that's your overall energy change. 2 key definitions, 2 very easy marks in the bag.
And finally, the last mark. We had to explain why this reaction is exothermic. Look, the simple answer is that energy is released. But to guarantee the mark, you want to use the language the examiners love. The mark scheme says it all. The level of products is below the level of reactants. Use that exact phrase, and you simply can't go wrong. So let's just step back for a second. What's the big takeaway from breaking down this one question?
Well, here are the big strategies. When you get a method question, your brain should immediately go logical steps and control variables. When you see a graph, think show my working and don't forget the units. And for those theory questions, use the exact scientific language from the syllabus. Honestly, this isn't just about chemistry. This is a blueprint for how to approach pretty much any science exam.
So now that you've had a peek inside the examiner's mind, here's a question for you. Which part of your revision are you going to change first? Because when you understand the code of the mark scheme, you're not just learning the content anymore. You're learning how to score points, and that's the real game changer. That's all for this explainer.